Hi, in this small presentation I want to let you know about new features and also bug fixes we have introduced in the version 2.4 of our finite element software NACS. So NACS 2.4 is mainly a bug fix release. However, we were also able to introduce some new features in the NACS core as well as in the graphical user interface. Let me first start with the new features in the NACS core. So at first, we already had support for directional coordinate systems, but previously it was only possible to specify one space direction. For example, if you wanted to define transversal isotropic material behavior that follows a certain coordinate direction of your material, something like that. If we wanted to do something like this, we had a widget that allowed to select certain regions, and you could specify a start group and an end group like depicted here, and that would result in a certain material direction that could be specified using that approach. Now we also added support for specifying a second space direction, and this is depicted here in the lower picture. The second direction also defined by a start group and an end group, and this will allow you, for example, to specify orthotropic material behavior. The next thing is the concentrated mechanical elements. Here we introduced support for coordinate systems. That means now you can use coordinate systems, and if you use node to ground concentrated mechanical elements, then you can use any arbitrary, any coordinate system that you want to use. If you want to specify node to node concentrated mechanical elements, then you currently can only use the Cartesian coordinate system. The next thing I want to talk about is the performance. So we were able to improve the performance of our solver. For example, if you use in the magnetical domain Biot-Savart coils, we right now have improved performance. That means that you can reuse already computed Biot-Savart coils, either if you resume a previously stopped simulation run, or for example, if you've got a static simulation followed by a transient simulation in the magnetic field, then you have just to compute the Biot-Savart coils once and can reuse them in the second step. Then we also improve performance concerning the result quantity computation. That means any derived quantities that will be computed after the simulation step is finished. Those are now computed much faster than before. And finally, we also added support for hyper-threading cores for Intel Xeon processor architectures. So this will also allow you to speed up your simulations. Then also some bugs were reported by our customers, and this is what we want to take into account right now. In the magnetical domain, we found that artificial eddy currents would occur if you have, for example, a static analysis step followed by a transient analysis step, and then at the beginning of that transient analysis step, it might be that spurious eddy currents would occur for some time steps. So that means maybe your simulation result looks like this, and then you won't see any difference between the new and the old simulation. But in a case of high conductivity in the materials, it might be that it looks like that. And here at the beginning of the simulation, you can see in the old solution that you've got eddy currents from the first moment on, which is of course not physical. Later on we will approach to the real simulation result, but now in the new solution you can see that it's correct from the very beginning on. So this could be fixed. We also were faced in the magneto-mechanical domain with too high eddy current densities, and this was the case when you were using the edge element formulation. And here, when the magnetic vector potential wasn't perpendicular to the velocity vector, then those too high eddy current densities would have occurred. This has also been fixed. And also within the magneto-mechanical interaction, we found out that the geometry updating wasn't done on all regions, but only on those regions where a Lorentz force density has been applied, or regions where the mechanical displacement has been used as convergence criterion. This has also been fixed, and now the geometry updating is done on all the regions. In the last part, I want to show you some new features in the graphical user interface. At first, I want to show you that we introduced a license status widget. So the license state can be easily viewed from within the graphical user interface. We just show which licenses are available, how many licenses are available, and which are already used. You can also see which user is running a license or using a license on which machine. And you can also check how many cores are used on your local machine. You can also check whether a certain simulation can be carried out with a certain or given number of computational licenses. So this is what we improved to the communication with the license server. You don't have to use any third-party tools anymore to find out about that. We also improved the user interaction in terms of error dialogs. So from time to time it might happen that you've got a simulation and you just moved your Python simulation file but forgot to move also the mesh file, or the mesh file isn't available anymore, and then the simulation could not be loaded. So right now we introduced handling for those problems. That means we pre-pass your simulation script, and if we find out that the mesh file doesn't exist, then we allow the user to select the new mesh file location, and the simulation will be loaded in the graphical user interface. Then another thing that might happen is maybe your simulation script is broken due to syntax errors, something like that, and previously you couldn't load that simulation script. And here we also found a solution. We will provide you with an inline editor that allows to directly modify the simulation script that you want to load. And then you can just apply those changes, recheck whether it's possible to load it now. And in case it is possible, the simulation project can be loaded, and later on you can save the fixed simulation script. Finally, it might happen that some unexpected errors still occur. And if this might happen, then we improve that dialog as well. We will show you what happened, but we also have a button that allows to directly send an email to us, to our support email address. And this will ease the bug tracing process on our side, and we will help you much faster to get that problem solved. The last thing I want to present is the job control. We already had a job control, of course. There were certain drawbacks in the previous implementation, so that means, for example, we weren't able to talk with our license server whether it's possible to start a simulation or not. We had to track all of that by our own. Now we completely revised the job control, and this is how it looks currently. The GUI layout changed a little bit. Mainly, one main change is also that we save every item that's available in the queues. So that means if you close the graphical user interface and reopen it again, then the same files will still be there in those queues. And if you want to get rid of them, then you have to manually remove them. We also modified the concept a little. So that means currently we have 3 queues instead of just 1 queue. Previously, we've got one job list queue where you can just put all the simulation jobs that you want to simulate in that queue, and then you can either enqueue those jobs and let the automatic job control carry out simulation after simulation, or you can directly start simulations on your own. Once started, those simulations will be transferred to a running queue, so you can see all the jobs currently running on your machine, but limited to your user account, of course. And then finally, you've got the list of finished jobs where you can see which jobs are finished, and so you can review what happened. We also have added support for Python scripting, so that means that you can also add or remove jobs from the job list queue using Python commands, and you can also modify the queue state of those jobs. Then we've got one list, the job list. So this is where all your jobs are going to that you want to simulate. And here you've got some items as depicted right here. You can add or remove jobs. Here you can modify the position in the job queue, and here you can directly start or continue or resume as previously stopped simulation. And here the red button that is depicted right here can also be changed to a green button, and this is the automatic job control that will process all of your jobs. You can also specify the number of processors or cores as you could before, of course. Then those jobs will be transferred to the running job queue, and here you can stop or you can terminate, so kill simulation jobs. And if they are finished, you can finally find them in the finished jobs queue. Here you can reschedule them and put them back to the normal job queue. You can directly restart the job from within that queue, or you can start post-processing, or of course get rid of those jobs in the finished queue. So the normal process looks like that. You've got your job list, it's transferred to the running jobs queue, and finally it ends up in the finished jobs queue. So this is everything that I wanted to tell you about the new version 2.4 of NACS. If you've got any questions, either visit our website at www.symmetris.de or write us an email either at sales@symmetris.de or write an email to support@symmetris.de if you're faced with any problems. So thanks for watching and see you soon.